In today's lesson, we're going to create asynchronous service objects to perform work in the background. So far, we've been working mostly within the request cycle or the console. In a real-world system, we would likely have to perform work that isn't triggered manually by an API request, a web request, or a console command. Or we would have work, like getting a large data set, that just takes too long and would tie up an HTTP request for too long. We might have a process that disables customer accounts when their subscriptions expire. We don't want to have to manually trigger all of those. We want to be able to schedule them to just run. To do this, we need to introduce asynchronous background jobs. For this next example, we're going to use a Ruby gem called Sucker Punch. There's a similar and more popular gem called Sidekick, but that gem requires external dependencies that we don't want to deal with now. In order to install Sucker Punch, you would add gem Sucker Punch to the gem file and then run bundle install. We'll use Sucker Punch for our examples, but the API of the gem matches that of Sidekick and the concepts are interchangeable. Remember that our controller action is processing an HTTP request, and these have time limits. Doing a lot of time-consuming work before resolving the request would not be possible. So we can resolve the HTTP request right away and let the user know that the process has been scheduled. We can create a background worker to handle expensive asynchronous tasks. These can kind of be looked at as a combination of controller actions and service objects that run outside of the main request cycle. We'll create our worker in the app/jobs folder and name it importer job. Assume that we have to do a massive import of a large dataset that was submitted. It's quick for us to save the dataset file and let the user know we got the file, but processing it and creating all the records is a much longer task. We'll want to work through the dataset and then notify the user it completed. Since the queue has to hold on to the params you send, it's a best practice to pass only primitives to jobs, like the ID of something, and not large objects. So we'll send the job our dataset ID and it will use it to query and run through everything. At the top of the class, we include the Sucker Punch job mixin. We then define a method called perform that we tell to expect a dataset ID. Then we query for the dataset and process it, creating all of the individual data records that would have taken too long during the HTTP request. Next, we notify the user things were completed. For something like this, we need some way to tell the user this asynchronous job completed, since we can't include that in the response from the controller. These background jobs have access to all the same things the rest of our application does, but they run in a separate process that allows our web application to focus on handling requests while our background process runs these async jobs. With more advanced background systems, you can actually schedule recurring work, like a report that's generated every Monday, or the subscription handling mentioned at the beginning. Let's look at one more example of a simple job that checks to see if any clients need customer service check-ins and schedules them with the customer service team. This job doesn't take any params. It's meant to be run on a schedule, and it looks for its own work based on the query that was written. It then delegates to another object to handle the actual check-in creation. The job is just focused on finding premium clients that need check-ins and letting the check-in service handle it from there. Jobs can be this simple or they can get incredibly complex. The important part about them is that they're able to run separately from the request-response cycle of the web or the manual interaction of the Rails console. I provided an example class. Fill out the class above to include the Sucker Punch job mixin, define a perform method that expects a dataset ID. The method should query for the dataset and process it by creating all of the individual data records that would have taken too long during the HTTP request. Last, notify the user by calling import completion notice.send